Okay, what is a I enumerator? Actually, is a iterator provided by C Sharp. So what is an iterator? We know that the for loop is an iteration, right? And actually, how the C Sharp execute your iteration is through some class called the iterator. So the iterator has a mandatory method, and the mandatory method is called the move next. It provides how to deal with the next operation. So I enumerator means that you have to implement the move next method, but you can temporarily skip the definition of I enumerator over here. You just need to be noticed that the return type should be set to I enumerator. And inside the coroutine, you see that the return is also different to the traditional way. We are going to add a yield keyword before return. You see that? Yield return. Previously, we just returned something, but this time we're going to yield return something. And the returned data is a little bit weird. We are going to instantiate a wait for second class to make it an object and return that object as an enumerator to somebody else's. So who is the somebody else's? Actually, next page. Actually, the answer is over here. The Unity coroutine is like a magic. It just creates a state machine for us. What is a state machine? So we're going to talk about what is a state machine later. And this is a very simple, very simple state machine. It's over here. We can implement a state machine just by a simple switch. Like this one, we have three different states. The first state is called 1, and the second is called 2, and the third is called 3. So this represents for three different object states. So if the object is in state 1, it will do something, uh, some actions which will be written over here. But right now it's empty. We don't do anything in state number 1. And of course, we do nothing in state number 2 and state number 3. This is just an empty framework. And if the state is outside of the three cases, we're going to throw an invalid operation exception, because we should limit the state to be only within these three states. And next, we see that, we implement a move next method. So this method is mandatory. And if you uh, if we want the class to be a child of I enumerator, it must implement move next method. And by the way, we should also implement the reset method. Otherwise, the compiler will send us a warning message. So this is what we have done in the very short code. Actually, the new wait for seconds just generate a state machine for us and return to the C sharp to the Unity engine. And the Unity engine will take it as a state machine to run from the initial state to the final state. If the final state is passed, is finished, and the whole state machine will be closed, we are going to take this as the end message of your coroutine. The coroutine just run once from the first day to the last day. So that's it. That's the simple things we can do by simply using yield return and something like this. So when in this example, we start a new coroutine in line 8, and suddenly we are going to execute line number 11 over here. And whenever we encounter a yield return, we are going back to the original task that is start. But before we encounter any yield return, we're going to focus at the coroutine. So since there isn't any code following the line number 8, in this example, we are going to do only the codes over here. So we're going to see the log message over here as the first message. No matter, we are going to see coroutine started, right? And then this state machine will lock the task for 2 seconds. So you will see the program just stopped for 2 seconds. And after 2 seconds, you will see another new log message like this one. It says coroutine resumed after 2 seconds. Yeah, correct. And later we're going to generate a new state machine over here in line number 16. And again, we are going to let the state machine to wait for 2 seconds. And then we're going to print a log message like this one, resume after 4 seconds, and do it again to wait for 2 seconds and print a message like this after 6 seconds. And the last one is return a null. Mr. Fu, why we return a null at the end of this line? Because we are going to return a nothing. We don't generate any new state machine, provide the machine to the game engine. So that's why we decide to put a null over here as the return object. So that's it. But Mr. Fu, I see somebody put a yield return 0 as the last line of the code. That is okay. You can put yield return null, or you can put a yield return 0. Both of these two lines works properly at this example. But if you return a 0, that 0 will be boxed and unboxed again. So that means if you put a 0 over here, it will generate some garbage in the heap. We don't like garbage, so we just put a null over here uh, in order not to generate any garbage in the heap. Okay, get it? All right. So we're not going to take this exercise because this is a little bit too far. It's just this example is just to try to explain what is a state machine and the theory behind the coroutine. Okay. Next one. All right, so this is what yield return happens, but I prefer to use a draft a sketch to introduce the idea over here. All right, so now we have a paragraph of code. For example, we are writing our start, and inside the start, we are going to generate a new task, which should be put in another CPU and or in another thread to run separately, parallelly in the program. So after we call the start coroutine, the control will be handled will be handed over to the coroutine. And whenever in the coroutine you found the yield return, aha, that means the control will go back to the start again. So we see that in the example, over here, we have 4 yield return, right? We have 4 yield return. Each of the yield return will hand over the control back to start again and again and again and again. But the first time the yield return just hand over the control back to start, the start will execute the following codes. Right. So if you understand the idea, let's take a look at let me see. Wait a moment. Okay, there is a very important example on page number 11. If you can understand the example on page number 11, then you are fully understand about what a coroutine is. But before that, let's migrate to the page 11 gradually, okay? So let's take a look on page number 9 first. So the example on page number 9, it shows how to call different routine accordingly or a serial in a serial manner. We see that in line number 8, we call first coroutine in the start, and then the first coroutine will be executed. And then in line number 14, here we wait for 1 second, and very soon we call the start coroutine again. And this time we call the second coroutine. So whenever we encounter line 15, we're going to the second coroutine over here. And the following code will be like print the log message and then do the yield return again. Okay, so in line number 21, this real yield return just finished the second coroutine. So we'll go back to where we code the start coroutine over here. Since this one is the last line of first coroutine, that means the first coroutine will be ended over here. So we go back again and we go back to the line number 8 over here and execute the following codes. Okay, we're not going to do the exercise over here. This one is just for explain a serial manner of calling coroutine. Okay, next one. So, Mr. Fu, now I know how to instantiate or initiate a coroutine. So how to stop it? And if in some moment I want to stop or I want to cease, I want to terminate a coroutine, how should I do? All right, that is a good question. If you need to stop a coroutine, the most important thing is to save the coroutine reference when you start it. So let's see the line over here, the line number 10. This line is different to what we had done in previous examples. In this line, we save the reference to a variable over here, and the name of the variable is my coroutine with a small case m in the beginning. So we have to declare this variable. We have to declare the type of it as a coroutine like this one. Right. So that means we can control the whole coroutine process, and we can understand the status of the coroutine. That is good. So we're going to try that. Whenever we press W key, we are going to stop the coroutine. So by simply call the stop coroutine over here, we can terminate the coroutine. But we have to provide the reference to the coroutine. So that's why we save it in the start. So in this example, again, we are going to wait for 2 seconds and do this wait for 3 different times. And in the middle, you can try to press W and the coroutine will be stopped. So I think this is a pretty simple example, so we're going to skip this one, okay? So the most important thing in this example is please do remember to save the reference to the coroutine if you want to stop it. All right, great, simple. Now, let's look at this very important example. Now we have to log some message to indicate whether the program starts or ends, and whether the coroutine is start or ends. So for common way to do this will be like we put a program start in the beginning and we put a program ends at the end of the start. Okay, that's a common sense, right? And in order to log some message about the status of coroutine, we put a coroutine A starts over here and we put a coroutine A ends over here. Okay, Mr. Fu, that is my solution. Any problem? Yeah, that is a huge problem. So we expect the log message will be like this. In the beginning, I suppose that the program start message will be logged. Then after that, my coroutine A will start. And after that, the coroutine should wait for 2 seconds. And after that, the coroutine A should end. And after that, the program ends message should be logged on the screen. This is a perfect log message for me. But unfortunately, you will get this. And I need your help to try the code and see by yourself clearly you get this kind of error message and think about why. Okay, so let's do the exercise on page 11. This is the first important exercise we are going to have today. And I need your help to try to think, try to figure out why the result is not as the expected one uh, we hope. Okay, so I can see some most of the students over here should already see the strange, very strange result over here. And okay, now let me introduce what happened within this short time. And I will need your help to look at this picture. So here the white blocks represent for the start of the code, the start program, and this one is the micro routine. This is a coroutine, and the red lines means the thread, the task of start. This is where we initiate the start task, and we run the task accordingly until we are encountering the start routine over here. Whenever we have a start routine, the control is going to the microroutine by following the green line over here. And then in the microroutine, we are going to encounter some EO return. So whenever we encounter a EO return, we just stop, temporarily pause the microroutine and let the control to go back to the caller over here. So the caller of this task is start. So a circle represents for the starting point of the coroutine, and the arrow represents for the end point of the coroutine. Get it? And then since you return, hand over the control back to start. The start can be resumed and execute the following code until the end of a frame. Okay, that's it. But since start only runs for once, the error will be terminated over here. If this one is an update, the control will go back again. All right. Mr. Fu, but the microroutine isn't finished yet. It's just the encounter and yield return, and there are a lot of things to be done, but yet never be done. Okay, yet never finished. All right. So we know that somebody over here is executing, is taking control over the game. Somebody, I don't know who he or who she or who he is, but somebody did take over the control of the code, right? So that body finish his execution, the engine will resume the coroutine from here. So the engine will try to resume the control of coroutine starting from here and let the coroutine to execute again. So you'll never bother with that because the engine is really smart. When he knows that, oh, every start and update is finished. Now all the coroutine go alive, wake up, and everybody do your rest of the things like this. So the engine will call the coroutine again. And again, inside your coroutine, there is another EO return. So you just hand over the control back to the again engine. And next time, when the game engine knows that, hey, now nobody is executing any code. Now all the coroutine wake up. So the engine just code the coroutine again. So we're live again. And if we do that again and again and again, your coroutine will finish at its last line. So that coroutine will be finished totally. So that's the execution order of coroutine and the engine task like start and update. So if you can understand the order of execution, so let's track the code for once again. We're starting from line number 6, and in line number 8, we print a message, and in line number 10, we go to coroutine A. So we're jumping to the line number 15 over here, and then print the message over here. Oh, and then we encounter our first EO return in line number 19. Great. So we generate a state machine and return the control back to start, back to line number 10, and execute the following code. And then line number 12, we're going to print the program ends, but actually the program doesn't end because there is another coroutine which is queuing, still queuing for execution like this. So since the red line is finished, but the green line is still active, the engine will know who is still running, the coroutine who is still running, and pass the control to the coroutine again. So that's why we are going to get a program ends before we see the coroutine A ends. Whenever we see a real return, and we are going to instantiate a new coroutine and hand over the control back to the caller. So that's why we see the log message will be like this. Okay, I need your help to understand the process in detail, and until you know, you can understand what I have to, what I described for this page. Okay, so this is a very important idea because most of the basic Unity learners, most of the basic users, they all expect the result to be like this. But unfortunately, the result is like the yellow one. And if you making your game without without the knowledge of this, you will write some buggy code. Okay. So now I think we can have a 10 minutes coffee break. But during the coffee break, I need your help to fully understand the idea of coroutine. Okay. So if you have any problem, you can contact with me. That I can explain the idea again to you. All right. Okay, welcome back. So let's continue the classes. And I will just talk about the coroutine, right? So even though you're not going to implement a wait for any seconds function, but if you want to use some special API, like reading a file or loading some HTML from internet, the API Unity provide is pretty like a coroutine. So later you'll see that over here, the purpose we are teaching the multitasking like coroutine or async await is because we need to use file open and HTTP calls in our game. But unfortunately, the official solution provided by Unity, they all use coroutine. So we have to understand what is a coroutine before we learn how to initiate a file open or HTTP call. So that's why this is important. Okay, great. All right, so let's move on to the next topic. And the next topic is async and the await. The async and the await is provided by C Sharp, not provided by Unity. So you can write this kind of code in all the C Sharp platform without importing any Unity package. It's provided by native C Sharp. All right. Okay. On the journey of learning async and await, if you search the related document on internet, there is a very, very confusing term called blocking and non-blocking. So before that, let me introduce what is blocking and what is non-blocking. All right, so over here we have two different sketch. The left sketch is showing the idea of blocking task. For example, we instantiate a task starting from a bubble, then we execute the content of method A, and then we execute the content of method B accordingly. But if method A takes too many times, takes a long duration to run for the task, then this one just block. The method A just block the whole procedure. So this is the idea of blocking. And if we switch or if we fork a different task for method A, since it consumes a lot of time. So we are thinking to put method A into another task or another thread. If this is what we are trying to do, then method A will no longer block method B. So this kind of programming style is called the non-blocking. So now you understand what means non-blocking, right? Non-blocking means we can execute some task in parallel, not in concurrent style. Okay, great. If you can understand when we can temporarily skip all the content over here. And okay, we know that the C Sharp is provided by some large company, and one of them is Microsoft. C Sharp provides a task-based asynchronous pattern, in short TAP, to implement asynchronous operation. Just like coroutine is provided by Unity, C Sharp also provide TAP if you want to do asynchronous programming. So if this is what we want, we typically use task and task of T. This is a generic type of task. So what is the generic type? Maybe you already know that because whenever we call a get component in Unity, we also put a angle bracket just after the get component, and in the angle bracket, we just pass a class pass a type of class into this angle brackets. So this kind of uh, is pretty like an extra argument, right? So this kind of declaration is generic. This is a generic type. This is an ordinary type. So if we want to use TAP, what we need is task and task of T. So with the help of these two different types, we can represent a asynchronous operation, right? So for the following paragraph, we can temporarily skip all of them. And what we need is the code over here, okay? So now let's do the synth without the help of coroutine and use some code like this. So we declare a start, and just like before, we print a before in the beginning and we print an after at the end. So within the code, within the body of start, we put the method A. We just invoke a method A in line number 10. So whenever we invoke method A in line number 10, we are going to line number 15. And after that, we are going to execute line number 17. And later we'll encounter the line number 19, right? This is a task, an A-way task. So here, the execution will fork into two different branches. One of the branches is going to be controlled by the delay over here. And the other control will be sent back to the caller and execute the following code. And for the method A, it will be temporarily locked, temporarily waiting for the end of the delay branch. And whenever the delay branch is finished, the execution of the branch is go back to the await position again and execute the following code. So whenever we see an await, actually the control is split into two different branch. One is for the new branch and the other is go back to the caller's branch. So this kind of await doesn't block anything because the caller gets a new control, so the caller can execute the following code over it. So this is a non-blocking design. But if we focus at the await part, the NAND really the NAND represent itself. It's just wait over here. So some student will misunderstand the idea. Oh, Mr. Fu, since this is waiting over here, oh, this is the blocking style of programming, right? No, this is not a blocking style of programming. The method A is waited here, not blocked over here. Can you understand? The method A, when it encounters A wait, it is waiting over here and split into two different branches, so nothing is blocked. And whenever the branch is finished, the A-way will resume. So nothing is blocked because the caller also gets a control. So it would be pretty like, uh, it just work like a coroutine, but in different manner. Okay, so since this is the first time everybody use async and await, I needed to spend about 5 minutes. Let's use 5 minutes to finish the code on page 17. For those people who finish the exercise, I have one question for you. You can take it as a special exercise. So the problem is, now you see the log output will be like this, right? So how to modify the code in order to let the after message to be printed at the length of this console message? How to modify the code in order to bring the after login message to the final line. That means you should reorder the execution of this program. Okay, one hint for everybody. That means okay, Maximilian. Okay, you have an answer? Yeah, correct. Perfect. Yeah. You can keep asking how to do it. Wait. Okay, just wait at where you want. Yes. So, sorry, we are running out of time. So, we have to show the solution to everyone. All right. So the question is how to let the after login message to be put at the last line. The answer is we should wait. We should wait at here. We should wait on line number 10. So if you need to wait over here, you can put a wait just in front of it. But this causes some problem. Sorry, I didn't implement the code. Let's go to the next page. If we directly put an await just in front of the method A and hit play, the compiler will report some warning message. It says that you have to put the await in an async method. So we also need to put an async over here. Otherwise, the compiler will not let us to compile the code. So the answer is we have to put an await, and in order to put an await, we also need an async. So let's have a try. Just put these two keywords on different lines like this. Uh-oh, there are some missing paragraph in the content. Sorry, but the idea is just like what I introduced before. Okay, with the help of these two simple exercises, Now you know how to wait within the code blocks whenever you want to wait for another multitasking uh, multitasking task like this. All right, now let's do some very interesting example. We are going to overload your computer. Don't be nervous, it won't be burned, okay? We just try to overload your computer with some for loop like this. So let's go to the next page. So the page we see over here, we provide an example code. The most different thing is here, the method A. In this method A, we see an enormously large number. How large is it? K, million, billion, 30 billion. Okay, you know that integer is not valid to represent for a billion number. So we have to declare I as a long number. So please be noted that we have to declare the variable here as a long number. That means a very long integer. Okay. So we increase the number of I gradually. So we run 30 billions of loops over here. It would definitely let you to feel something is slow and sluggish. And at the end of the loop, we try to log some message. We try to log an end of method A, and we just put method A to show it in the console. This will block the execution of your Unity game. So whenever you block your Unity engine and you try to press W on the other side, it will not respond to your W key. So next, let's run the code over here and at the same time try to press W. And you should observe the result of the W. You'll see that there isn't any response. And after the execution of 30 billion looping is finished, then your W key is live again. So this is very interesting exercise. All right, let's use 5 minutes to implement this exercise, okay? Your computer is better than mine. You need a much more larger number to get your game to be hot. But I think 30 billion is enough. Okay, you can work at the moment and listen to me at the same time. If you finish the exercise, try to think about then how can we do the super large loop while making the W key live at the same time. Can we do that? Can we use coroutine or async a way? How can we run the loop at the same time without blocking the scan loop? Okay. I will explain the solution 2 minutes later, okay? But before that, you are encouraged to think to provide your own solution and you can have a try. You just fiddle around your code and try to pass the method A into other tasks. All right, so sorry, we are running out of time. We're going to finish this part, this this whole chapter number 3 today. So let me introduce how to solve the problem of this overloading method A right now. So the answer is we are trying to move method A to another task. But before that, I'm going to explain why start will block update. Mr. Fu, my code is in update, but I am blocked in start. So why a blocked start will take some effect to block update? What's the execution of order? I can understand. So let's go back to the order of execution for Unity. Sorry. All right. I don't know how to turn in dark mode. Just 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 looking at the demo. Okay. So we know that this is the life cycle diagram of Unity. So after the game is executed, the first API to be called is the awake of every game object, and then the onEnable will be called. So if you have hundreds of game objects in your game, that means there are hundreds of awake call to be waiting over here, to be queued over here. So after you execute the whole 100 awake call, and then you move on to the next stage, that means you are going to call 100 of onEnable in this stage. And then the next stage is calling the reset, and again, we are calling 100 of reset, the reset of every game object over here, and do the 100 call of star over here, and do the 100 call, blah, 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 blah. So each of the calls, each of the API calls to be called here is just one game object from your game. So if you have thousands game object in your game, each of the stage will call thousands of the APIs accordingly. We see that uh, sorry, the start is over here and the update is over here. So if you are blocked in one of the 100 start call, then not only the whole start, not only the rest of the start code will be blocked, but also the whole update code will be blocked too. So everything just right after the block, the code will be blocked because this is executed in a serial order, right? So that's a very dangerous thing. So in order not to be blocked in your start, we have to make the method A to be executed asynchronously. Next. So the previous way means before Unity 3D is invented, there is only C# package and the framework. At that time, you can use task. You can use task to bring some method into other task. So like this, we're going to instantiate a new task, and we pass the method A as the only argument to the constructor. So then we can get a task. We are going to save the task into this variable. Actually, this is a reference. So in line number 12, we just call the start method belongs to task. This will start the task. Simple. And this will solve the problem. So let's have a try. Please put the line 11 and 12 into your codes. And this time you can see that the W key works properly. Okay, so I think by simply tweaking your code, like the page over here, you can see that when this time when you run the program, nothing will block you. You can directly use your W key to show the message on screen. Alright, that is really good. Okay, so if you like to use the new way to declare, just like using async and the await, then please move on to the next page. So here we provide the same thing, but with another declaration. But this time we're not going to declare a new task. On the other hand, we're going to use the async and the await. So in order to call method A asynchronously, we have to declare method A as an async function. But once we turn the method A into async, it should return a task, not a void. So you can see that we changed line number 23 in the declaration. We set it to async task and the method A. And within that body, within the method body, we should put something into a weight paragraph. That is because when the code encounters a weight, it will turn half of the control back to the caller. So that will make the start to resume again and not to block the code. And in order to put the a weight, you need to write code like this. You need to declare your lambda function. We put all the code into a lambda function and pass the lambda function to task run. So this is a lambda function. Do you remember lambda function? Yes. Mhm. Okay, I need your help to finish the exercise over here. And when you finish, please take a look at the final question. And if you can solve the final question, that means you fully understand what is the async and what is the await. And the question is, right now you will see the function works like this. When you play the game, it shows start ends very quickly, and you can control your W key. And after some period, you will see the huge number is printed out. I don't like it. Mr. Fu, I just like the start ends to be printed after the loop is finished. How to do that? Well, again, uh, mm, I'm not going to disclose the answer. You can take a try. Okay. I think you are already know the answer, so you can have a try. How many times we left? Sorry, let me see. So we're going to skip the procedure part. Okay. So we're going to spend 5 minutes on this question. Okay, we're going to spend 5 minutes on this question. Okay, so I think you should understand the async and await right now. A simple idea is that whenever you need to wait at some point in your program, you just put an await, and later your compiler will talk to you. What's the is there anything missing that for an await call? And you can just follow the instruction provided by your compiler to finish the code, and that await should work. And for something like this declaration, this is the special part of this program. So whenever you need to put some program into a new task, you can remember the lambda function and the task run part of the code like this. Okay, so Mr. Fu, I want to return some value from the task. How should I do? Okay, let's see the page over here, the next page. If we want to return some value, for example, we want to return some integer like this, we just return 888. The only thing we have to do is put a generic type setting in the task part over here. We remember that we just changed the return type of method A to a task. But if we want to return some value, we should put a return type just in the angle bracket and concatenate the task with your return type like this. This is a generic type. So if we declare our method A like this, we can return some value. So whenever we call the method A, we can get the return value uh, from method A and save the value to other variable. So this time we put a weight over here. Okay, so I think this is very, very simple. We are going to skip this exercise, all right? Okay, so I think we can take a 10 minutes break. And after that, we're going to explain what's the difference. What's the difference between a process and a thread and a task. So, and after that, we are going to explain the most difficult part of today. We're going to use a file and HTTP. That means we can open some file in Unity or to read some internet pages from HTTP. Okay, right. Let's take a 10 minutes coffee break. Okay, welcome back. So let's continue the PowerPoint. Okay, so next we are going to talk about what is process and what is thread and what is task. I know that the content over here is a little bit too much for everybody, but you can go back to when back to your home, you can read through the contents over here. And I'm going to introduce the basic idea, especially the differences between process, thread, and task right now. Um, Actually, what we have do today, what we have tried today is task. But task is an abstract. Task is an abstract unit of operation. The real operation is executed in thread. The reason why we're using task, not thread, is because thread control is tedious. Thread control is a little bit complicated, and there are some problems will be arised if you choose thread to be your multitasking solution. So the important sentence is listed over here. I color the character in yellow. A thread is the smallest unit of the process. Small is the unit. So if you want to run some code in a different thread, you can choose a thread from a thread pool. A thread pool is running in your OS, in your operating system. And there are some existing thread. You just pull a thread over and use the thread to run your process. So there is another word called process. What is a process? Actually, every time we press Control Alt Delete, we can use the manager, the job manager. Sorry, my job manager is in Chinese version, but you should see the sandbox in your computer, and then everything over here is a procedure. Everything over here is a procedure. Procedure. Each of the procedure will occupy some memory. So it's the duty of procedure to ask for some memory and keep the memory on hand for further processing. So this is a procedure. So procedure will take the responsibility of asking resources like ask for the time slicing from CPU. Time slicing means how much time you can use, and the slice is shared with the other things, other procedures. So you have some percentage you can occupy the CPU and use the CPU to calculate your operation. So all these resources is allocated per procedure. All right. For your task manager, there isn't any information about thread. You have to install some other manager from where is the Microsoft store? Uh, where is the store? All right, never mind. You can download some special version of the task manager and from the Microsoft store, and that version is able to show some thread information in the list. Mine is not able to show thread information. Okay, so thread is the minimal, is the smallest unit as a resource of computer processing power. Okay, so that is the idea between process, thread, and task. So when I was a student, there isn't any solution for task. Every time we want to do multitasking, we are using thread. That is really a nightmare because you have to dealing with the synchronization problem. If you change a variable in thread A, that means thread B doesn't know the change. So how to notify another thread that, hey, I just changed the variable content. You should be noticed about that. So this is a very, very tedious problem. So the best policy is to separate the variable to limit the usage only within the frame of a thread. This requires some programming skill, especially design pattern. You need to know design pattern in order to separate and limit the scope of a variable. But that is another story. Right now, we are thankful because C# provides tasks for us. So some tedious problem is solved by simply using task. Okay, next. So this is a very simple comparison table to compare between process and the thread and the task. For isolation, yes, process is fully isolated. In order to communicate between process, you have to know some special solution like IPC solution. For example, if I write two EXE file and I hope the two EXE file can exchange some data, how can I do? Even I didn't talk any knowledge about that. Maybe you have some experience. Some program can open an HTTP port in order to let the other application to read some message from it. So if this is the case, it will use a local host starting from, you know, local host, local host. Sometimes you can open a local host, but right now I didn't use the local host. And you should specify the port you want. Typically, we use the port starting from 8,000, and maybe sometimes you use some port starting from 20,000. But how many ports you can use depends on your firewall. The firewall will block most of the ports and leave only several of the ports be available for your inter-process communication, or you can expose the port to the outside of the internet. This is local host. Sometimes we are not using local host, we are using the IP representation of a local host, like this. 127.0.0.1. This is your local host. All right, so writing a local host communication is much more tedious than other solutions. So the isolation brought by process is really high. And the creation of overhead to create a process, you have a really, really high overhead. You have to allocate the memory and get your time slicing of CPU and maybe ask for the usage of internet and blah 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 blah. And you have to take so many resources on hand to initiate your process. So the overhead is really high. Compared to process, thread and task will be a better solution for multitasking. So for the solution of communication, if you want to separate your operation into another process, you need to design some IPC, inter-process communication, just like the local host the way we just talked before. And on the other hand, if you try to communicate between two threads, one way you can do is to use shared memory. Just use some variables between two different threads. But you need to be cautious because if somebody is writing the memory and the other ones don't know about that, that will cause a conflict. And the conflict would typically cause the program to be crashed or be more function. And for task is easier because you can use the async and the await to do inter-task communication. All right. So for process, typically when you're running separate applications, you are going to use different process. So that's is the stand to our knowledge and experience. Um, with the help of process, we can run different application. Sometimes they can communicate each other. It depends on the design. And for thread, Sometimes we need a concurrent execution within an app. If this is what we want, we can consider to use a thread as a solution. And for about the task, if we want an asynchronous programming in order to separate some heavy loaded or overloading operation, we can use the TAP solution provided by C Sharp. Right, that's the point in this chapter. Okay, we're not going to go through the whole exercise over here. Just take a look at this paragraph. If you want to call, if you want to instantiate a Notepad++, uh, does anybody knows Notepad++? This one, this application. This is a really handy text editor, A, B, C, D, E. You can write anything inside this. So this is a very small and very quick application as a text editor. So we can instantiate a new process in Unity. If we run the code over here, your Unity will open a notepad, and the notepad will be open and minimized over here in your toolbar. So with the help of this line of code, you can open notepad in Unity. Of course, you can get the process ID, but in order to send some message, you need to find some IPC solution. Next. All right, so in this example, what we see is we're trying to use a new thread. We're trying to use a new thread to run some method. Just like I said, I do this since 20 years ago, but I don't think right now is year 2024. You don't need to open a thread if you want to run some parallel tasks. So we are going to skip this one. And this is what we had learned in the previous slides. In order to instantiate a new task, we can use new, or we can use the lambda function, or we can use the lambda function with an await code in its caller. So this is what we had learned in the previous slides. Great. All right, so let's finish the process part. So next part is about the file operation. We care about how to input and output to a file in Unity. So the simplest solution may be that we can just skip the description of the solution. So let's directly dive into the code over here. What's the page over this one? Okay, this is page number 32. Page number 32. So in the code here, we are going to combine a path with a file name. So here comes a problem. Mr. Fu, what is this? What is the application dot streaming as a path? What is this? All right. Actually, uh, we can search the term on internet. Application dot streaming and as a path. And you're going to find the Unity manual page. Let me open the page and introduce the idea for you. Now this one, streaming application, streaming path. Maybe I should think, I should search Unity folder path. Now this page, Unity folder project, no, file. Wait a moment, please. Uh, okay, sorry. I right now I can't find the official page, but it's okay for me. We can explain the idea just by our PowerPoint slides. Before I introduce the code, uh, I'm going to um, I'm going to explain the structure of Unity storage. We have a storage. We have a data storage in different platforms. And on different platforms, Unity saves the data to different folder. So you just don't know the actual folder at the moment you are doing your programming. You didn't know the name of the folder. So how can we operate the folder? How can we save or load some file from the folder since we don't know the exact name? Get it? Because some structure of the folder, especially the name of the folder, will be decided when you install your application. That will be happened on Android platform. Every time you install your APK, it will save the whole file of your game into some folder. But the name of the folder isn't expected when you are doing your programming. So that's a key problem. So how do we know the program folder and how can we save and load file from it? That's the problem. So Unity solved the problem by providing a variable from here, application.dataPath. And Unity provides several different data paths for you. One of the data paths is the streaming asset path. This data path could be accessed uh, in your Unity project like this. So I need your help to create a folder with exactly the same name, like streaming assets. The S A should be in capital, and don't forget the plural S at the end of the folder name. Streaming assets, streaming assets. And after you have this folder, all the things that you put into the folder could be read by the program. Okay, so now we see that we can access the folder by simply reading the application dot streaming as a path. So this reference will direct you to the folder over here. And right now, let's create a task file inside the streaming asset folder. We can right click and choose create. And is there any task file? No, no, no. Okay, forget about it. Just right click and select show in Explorer. Show in Explorer. And that will open a Explorer for us. And again, let's dive into the streaming assets and right click to create some test file. So this time I'm going to name my test file. Sorry. So create a test file and I'm giving a name test.txt. All right, this one. And double click to put some character into the file and just put the ABCDE and save the file. Test.txt and the ABCDE. All right, now let's write some code to read the content of this file. So if we can do that, that means we can take this as a save file for our game. So next time we can load the character information, the game status, or the inventory status, the inventory values from an external file. So this will greatly enhance our work, give us more flexibility to build our game. All right, save it and go back to the slides. Now, looking at the line number 10, we use a combine. This is provided by C Sharp. The path naming, and this is a namespace. This package is from system.io. Within this namespace, we have a path class. And under path class, we have a static method called combine. We can call combine to combine two strings. And the combine can add a slash between the two strings for us. You may consider that, Mr. Fu, this is too basic. I don't need this API. I can just add a slash by myself. But here comes the problem. On Windows system, you should use a backslash to separate to integrate your path. But on Linux, you should use the ordinary slash to combine your paths. So it depends on the OS system in order to choose a slash or backslash. But since we need to write once and implement and deploy multiple times and to multiple platforms, we are not willing to deal with the slash problem over here. So we just use combine, and that combine to bother with the problem. Get it? Okay, so after we combine the string, we can get the correct path for your corresponding platform. And then we can call a custom API, a custom method, which is having a name read file async. This is a custom method. We're going to write the content for it. And please do remember that we call our custom method with a keyword await. So that means we are doing a asynchronous call. All right, let's dive into the refile async. We pass the path into the argument, and we can read the file path back again. So starting from line number 17, here we create a temporary string, which having a name content. So here we just initialize the content with the empty string. Okay. Then we are going to use a try catch block. What is a try catch block? A try catch block means the code we're running right now probably will generate some error message. And I'm afraid that error message will block the whole procedure like a blue screen. You know that? Or like some uh, very serious situation. I don't like that. So I need you to try to run the code. And if there is any severe error, you can catch for me and show the error message to me. Do not stop the execution of the procedure. That's what I want. If this is what I want, then I should use try catch. Can let me get free to the error message. The error message will not cause the procedure to be crashed. Great. So what kind of error message would I encounter? One possible is that there isn't any file which having the name test.txt. If there isn't such file and I'm enforce the program to open this file, it will cause a severe error and probably your code will crash. So in order not to let the file open things to crash, I put the open in try. So get it? Hmm? So here we see that this is provided by C Sharp. I use file.readoTest async. So again, since this is an async call, I can put a await in front of it. So that's it. So my program will wait over here until all the characters from the file is read into the memory. So by calling this method, your file is located in hard drive, right? In your hard drive. And then all the character, all the A, B, C, D, E will be copied from your hard drive to your RAM by simply calling this. Okay. So after that, everything is within your RAM, and we should put the information, we should save the reference to the characters, to the strings, and it should be stated in the content variable. So that's why we put line number 20 like this. And whenever the reading is finished, the code execute the following pass. Sorry, execute the following pass. It just return the whole red characters, or red string, and return to the code over here. And since there is a await over here, it will be waiting over here. And then the whole content will be printed in line number 12. All right. And let me see. Okay, we can spend some time over here since this is the first time everyone try to load the file into memory. So we are going to stop it here for 5 minutes, okay? For 5 minutes. Look, there are so many await over here. If you don't know what is a await and you read the example directly, you'll get a mess. That is because you don't have any idea about what the await is. So this is important to know what is async and await before you learn this example. Yes. Okay, if you finish the reading part, and you can go to the next page because next page is writing part. So let me introduce when you're working right now, and what you can find in next page is that there is a line number 17. We rewrite anything and we call the new method as write file async. And in line number 11, we call this write file async and trying to write something to text.txt. And in line number 17, we just organize a paragraph. Sorry, this is in Chinese, but you can turn this in anything you like in your language. Like, hi, what can I do for you? Like that. Do you need any service? And in the line number 20, we call another API provided by C Sharp. And the API is write all tasks async. So by calling this API, you can write the content into the file. So this is pretty simple and pretty simple. And with the 8-way modifier, we are going to call this writing operation separately in other tasks. So just like before. So if the error is happen because there isn't any file with the correct name, you will encounter an error message. And at this moment, the try catch block could be a help, and the error message could be taken as an exception, and you'll get the message here. All right. So please spend another 5 minutes to exercise the code over here. So if you finish both of the exercise, try to implement to append some character at the end of the current text file. This means that you have to read first, append, and then write again. So append means you have to combine both of these operations. But actually, you have a append API. Okay. Okay, so let's go back to the example over here. All right, so throughout these two different examples, one is for read and the other is for write, you can do some simple operation to your file. That means we can load extra data like a small database, which is having a CSV format. We can load our student score, we can load the character feature or load some game status from external file. And with the help of the knowledge we introduced in the first class, do you remember the class object, the JSON object? We download a plugin to import JSON object, and we do some serialization operation at that time, right? We turn a JSON object into a string. So if you remember that, now we can do the things like that. We can organize our data structure and serialize the whole data into one string and write into the file. And next time we can load the string from the external file and loaded the string into C# plus object or loaded the string into JSON object. So that is the serialized and deserialized operation. We do it in daily life. We always loaded the external file to the software and use the data inside the software. So now you know how to do that. But in order to do the things in a much more effective way, we may consider to use string. But today we don't have enough time, so I need your help. When you back to your home or your dormitory, spend some more time to read the 2 pages over here. The 2 pages on here is talking about how to use a string as a reader and writer and to write your file and read your file quickly. And you may see that there are some using passage. This is using. So what is using over here? Okay, we should be noting that the using high above and the using in line number 15, these two using cases are different. The usings above the code, for example, over here, is try to import some package into this code. So the using over here means that we are using some external codes over here, codes. And the using over here indicate that we are using some external resources over here. So now you can understand the difference. The using high above is to declare that we're using some codes from outside. And the using over here is trying to indicate that we're using some external resources from outside. So we see that the using on line numbers 15 and 16, this is an concatenated using passage. And after the using is declared, we have a curly braces, a pair of curly braces. What does it mean? That means the resources we get is only valid throughout the curly braces body. Once we leave the curly braces body, the resources is not guaranteed to be alive again. It could be collected and recycled. So just like we see that over here, we declare a file stream which occupies some memory, and we declare a reader to operate with the file stream in order to read it really like a file. And the fs and the reader are valid only within from line number 17 to line number 23. Sorry, line number 24. Once we leave line number 24, all these two things are not guaranteed to be usable. Highly, very high possibility that these two things will be recycled by the garbage collector. So get it? So that's everything about using. This is for code and this is for resources. Okay, using. All right, now here comes the last part. We have 7 minutes left. We're talking about how to use HTTP call. We all know that an HTTP call is a protocol in order to let us to load some message from internet to do some data exchange with some server. So this is a protocol. The popular protocol, one of the popular protocol, maybe I should say a form, is RESTful APIs. REST API is the a format of an API design. And the feature of REST API is that the command is pretend to be a folder name. So next time when you see somebody is trying to maybe like this, if I develop a server and the IP of the server is over here, I try to read a name from ID number 001. So I can call the server with the help of of an address like this. And when the server gets the address, it can parse the string of this address and it can notice my intention by simply reading each block of the address. So this is very delicate, very cool, right? Read the name of member 001. This kind of format is called the RESTful API. RESTful, RESTful, RESTful API. It's not the original version of REST, but a variant of REST. We call this kind RESTful APIs. But we are not going to talk about what is RESTful API today. We'll just try to load example page from internet. Okay, this is the last example we are going to deal with. Unity provides its official solution for us to load a web page, and the solution is called Unity Web Request. This is a class. So we can use Unity Web Request .get. This is a static method, and we can pass our argument, and the argument is the web link, the web address that you're going to download, and then it will return a web request object. Since this is the resources, I would like to put it into a using. Okay, and then okay, we see a yield return. Actually, the web request uh, if we call the send web request method inside web request, it will return an iterator. So that's pretty similar to wait for a second, right? And the code will wait at here. Once the web request is finished, we can ask it the yield return. We can go through the yield return and do the following things. So now the result is not empty. At least it will show some status like an error message or successful message for us. So we can use a switch in order to tell whether the result is successful or not. So we may have these four different cases. The first case is connection error, and the second case is data processing error, and the third case is protocol error. These three error messages indicate three different error root cause. The connection error means that your Wi-Fi is not being there. You may losing your Wi-Fi connection. That time you'll get a connection error. And for data processing error, it means you are connecting to the server, but the data is incorrect. Maybe the protocol is incorrect. Maybe the version is changed, but you didn't notice about that. Maybe the data structure is not valid, something like that. And this time you'll get a data processing error. So what is a protocol error? A protocol error means HTTP asks for your a package to be like this, but actually your package doesn't look like this. The most common problem is that you call an HTTP server with HTTPS, Have you ever heard HTTPS? HTTPS is the secured version of HTTP, but these two protocols are not the same. So if we call a HTTP server, but with the HTTPS protocol, you will get a protocol error. And the last one is success. Oh, finally, okay, this is the best one we can have. So if the result is success, we can further load the content into our variables. So we can read the content like this: the web request dot download handler dot text. So all the text we need is over here. This should be the content of the website. All right. So finally we get it. So again, this is a coroutine. In order not to block like a W press, like any key press, we hope the loading process to be in a coroutine. So that's why we declare this method as a coroutine like this. And furthermore, we know that in coroutine, the yield return should return some state machine, right? State machine. So this API will create a state machine for us, and the state machine will be ended while it receives the whole message from internet. So we are going to wait at here, and after we finish the connection, we finish the request, we get everything. We can parse the result like this. So this is the whole thing we should know when we're using a HTTP on the Unity 3D. I'm sorry for that. We didn't have further time to finish the exercise, but I need your help to finish the exercise on page number 40 and 41. Okay. Uh, Actually, 41 is not necessary. Since you know how to use coroutine to load a web page, that is enough because what addressed in page number 41 is a much more difficulty way. We are using the C# HTTP response message class. This is not belongs to Unity 3D. This is a C# class. But I just listed the information here as a reference for you. If you don't like to use the coroutine, if you want to use the basic way, an ordinary way provided by C#, then you can follow the page number 41, right? Right. Any question or any problem? Okay, I hope you enjoy the class today because the most important thing is to load a file and read the HTTP. So in order to do that, we introduce coroutine and async await. I know that is not easy, but this is a advanced class. All right, thank you for your attendance. Let's call it a day, and see you next time. See you next week. Okay, bye bye.